So in problem 6 here, it tells you that the length of the base of an isosceles triangle. So when you're looking at an isosceles triangle, the two equal sides are your legs, and the base is the non-equal, so 62.98. And it says the length of each congruent side is 37.48, and it wants you to find the length of the altitude from the vertex to the base. So the altitude is a perpendicular distance. It's the height of the triangle, so I'm going to call that A. And a couple things to keep in mind for this. Because if you were to imagine the full circle around this isosceles triangle, and because this is isosceles means you could think of it as being a triangle that starts at the center of a circle, and these equal sides are the radii of that circle. And so if you think of it this way, you have this chord that has a perpendicular through it, and this perpendicular passes through the center. So that is going to do what to the base? It bisects that base. So what you know for this particular case, or this particular triangle here, is that if we took 62.98 divided by 2, we get 31.49. That's the length of one leg. We have our hypotenuse of 37.48. And so what we can do here is use the right triangle and Pythagorean theorem to solve. So if you took 31.49 squared plus a squared, set that equal to 37.48 squared, and solve. Okay, so I'll subtract 31.49 squared from both sides to extract the square root. So if I do that all in one calculation here, I'll just take the square root of 37.48 squared minus 31.49 squared. Close that off. Again, I want the decimal form, so I've entered a decimal. It'll display it in decimal form. And so I get 20.33 approximately as my value for A.